What comes to mind when you think of metal? Strength, density, maybe the solid clank of steel hitting the ground. And one absolute certainty: metal sinks. We build massive ships and towering skyscrapers from it. But we all know if you drop a solid piece of metal into water, it's going straight to the bottom. That fundamental rule has been true for all of human history. Until now. Scientists have created a metal that does the impossible. It floats. No, this isn't a trick. It's not a hollow shell or some weird coating that traps air. This is a solid metallic material engineered at a microscopic level to be lighter than water. Even if you scratch it or poke a hole in it, it just keeps floating. This isn't just a cool party trick. It's a breakthrough that could completely revolutionize how we design everything from ships and planes to spacecraft and even rescue equipment. So, what's the secret? It's not about the type of metal, but its internal architecture. Think about regular metals. Their atoms are packed together super tightly, which is what makes them so dense and heavy. This new class of materials, sometimes called metallic foams or architected metals, changes the game. Scientists have found a way to introduce countless tiny, precisely engineered air pockets throughout the metal's structure. Picture a sponge made of titanium or aluminum, but one that's incredibly strong and rigid. These microscopic pores slash the material's overall density without making it weak. In fact, some of these floating metals are strong enough to support heavy loads while bobbing on the water's surface. What makes this so incredible is its durability. We've had lightweight materials before, but they often failed the moment they were scratched or punctured. This new floating metal is different. Its internal structure is designed so that even if the surface is damaged, water can't flood the material and drag it down. It stays buoyant, stable, and ready for action. Researchers achieve this by controlling the exact size, shape, and distribution of the pores as they make it. Some methods involve injecting gas into molten metal, while others use advanced 3D printing to build the structure layer by tiny layer. This gives them incredible control to fine-tune the metal's properties for any job, making it lighter, stronger, or more flexible as needed. The potential applications are mind-blowing. In the maritime world, this could lead to ships that are virtually unsinkable. Imagine a cargo ship's hull getting breached in an accident. Instead of taking on water and going down, the ship itself remains buoyant. This could prevent countless maritime disasters and devastating oil spills. Then there's aerospace, where every single gram counts. Lighter metals that don't sacrifice strength mean better fuel efficiency, bigger payloads, and more capable aircraft, satellites, airplanes, and even future space stations could all be built from materials that blend the toughness of metal with almost impossible lightness. It could also be a game changer for disaster safety. Think about flood-resistant buildings, floating emergency platforms, or life-saving rescue gear that won't burn, corrode, or melt like plastics can. But the benefits don't stop at just floating. These metallic foams are also amazing at absorbing energy. When you compress them, they crumple in a very controlled way, making them perfect for impact protection. This property is already being explored for car bumpers that can absorb crash forces more effectively, protective barriers, and maybe even next-generation body armor. This entire field is part of a huge shift in engineering. Instead of just mixing different chemicals to make new alloys, scientists are now designing materials based on their physical structure. By shaping matter at the micro level, they are unlocking properties we never thought were possible. And in a way, we're just catching up to nature. Bone, for instance, is incredibly strong, yet lightweight because of its porous internal structure. The same is true for wood, coral, and the hollow bones of birds. Floating metals are just humanity applying that same brilliant principle with modern technology. Of course, we're not quite there yet. Manufacturing these advanced materials on a large scale is still expensive, and they need more long-term testing to ensure they hold up over time. But the progress has been incredibly fast, and as the technology improves, the costs are dropping. We've already seen the prototypes, solid blocks of metal floating calmly in a tank of water, and structural parts that absorb massive impacts without breaking a sweat. This discovery forces us to rethink our most basic ideas about the world around us. It shows us that the properties of materials aren't set in stone. They can be engineered. Strength doesn't have to mean weight, and metal doesn't have to sink. A floating piece of metal is more than just a scientific curiosity. It's a sign that even the most familiar materials still have incredible secrets waiting to be found. Thanks for watching. If you want to keep exploring the breakthroughs that are reshaping our world, make sure you follow Tech Obsidian. We'll see you in the next one.